Michio Kaku has made such great contributions to the fields of material science that the James Webb Space Telescope has seen 6 huge buildings that scientists thought were impossible to exist. There is a good chance that these evaluations will give us new ways to think about how the world works. The openness is both fascinating and a modest way to test current ideas about how universes are getting better and growing. It's important to keep an eye out for these updates, and the fact that they were confirmed by people who were thought to be experts makes these finds even more important. As a physicist with roots in both the United States and Japan, Michio Kaku is an amazing person in the field of science. People think he knows a lot about both traditional material science and quantum physics. Kaku has been more open to the amazing and cocky results of the James Webb Space Telescope project than some more moderate and problematic experts in the field. His eagerness to accept new information and share it with the public shows that he wants to help us learn more about how to understand the world. We are glad that this person who is thought to be an expert has decided to stop keeping quiet and tell the truth, which can never be rejected again. The passionate tone of the famous physicist's comments about what the James Webb Space Telescope found is easy to pick out. It sounds like this has been an improvement that has sparked his interest again. Come with us as we look at what happened after Kaku revealed these 6 Titanic buildings. There is an expert named Kaku who has always been able to come up with new ideas. He is open to ideas that go against what most people think. For example, he knows that Einstein's theories of relativity and Newton's laws are important, but they don't fully explain how the world works. While Kaku thinks that the new telescope's findings could help the field of astronomy, many of his peers still feel differently. This makes people who believe in the Big Bang and critics of quantum physics nervous and concerned, but it makes Kaku laugh. 6 huge universes that go all the way back to the beginning of time have been found by the James Webb Space Telescope. Even though they were formed only 200 to 700 million years after the Big Bang, each of these huge systems has more stars than our own Milky Way. These amazing endless frameworks were found by a group of cosmologists who called them universe breakers. If proven, they would completely change how we think about the world. The impact of these revelations is huge, showing that the early years of the universe were unquestionably more unique and complicated than was thought before. The Big Bang Theory says that after the event, the world was very chaotic. For millions of years, the first solid things were formed, and it took even longer for them to get dense enough to give off light. It was thought that complex formations like galaxies didn't form until much later. Some of the new big systems found are bigger than the Milky Way. They are also very bright, which means they probably make a lot of new stars every year, while our galaxy only makes stars sometimes. As of now, experts haven't come to a decision on when the first structures were built. One thing that is certain is that there may have been only one or a few stars at the start. Over time, these stars may have joined together to form bigger structures. Bigger, crazier frameworks were served by smaller systems. People used to think that such huge and complicated systems couldn't have existed at that time. This makes us wonder if the world is much older than we thought, or if such huge systems formed much earlier than we thought. Moderate science still has problems with this model, so it's hard to see how this case fits in with it. Some areas of material science have flatly denied these findings and called age figures into question. Kaku knows this and said, "There are many models and old hypotheses that stubbornly persist because of the influence of some subject matter experts. Fundamental analysis showed that many of these theories were wrong, which was scientifically proven. In all sciences, but especially physics, the truth lies in the work of experimentalists who test the theory and make sure it stays on track. In all honesty, we don't know much about how the world began here on Earth." Kaku went on. This answer shows how important it is for the scientific method to keep testing, updating, and confirming. An idea about how things came to be was first put forward in 1927. It was based on observations of the expanding world. Based on these numbers, scientists have come to the conclusion that the universe started as a single point that was infinitely dense and has been expanding ever since. It was hard for people and scientists to picture a world with both a start and an end at that time. People couldn't understand how an eternal world could be possible. Even now, experts are still not sure how to fully understand it. But it's still important to think about these options, even if the new discoveries don't fit with the idea of how things began that scientists have been using for a long time. Science has shown over and over that being open to new ideas and reevaluating old ones are important parts of the scientific method. People used to think that stars and planets were fixed in the universe and that their positions formed a space. This is similar to how Einstein's early observations and hypotheses were confirmed. But now we know that everything in the universe is moving. Planets move around stars, stars move at speeds of a few kilometers per second within their own galaxies, and galaxies as a whole move quickly through the universe, though we still don't know where they're going. This new and surprising view of the world goes against long-held beliefs and shows that our scientific thinking needs to be open to questioning and change all the time. Researchers today have to be able to spot oddities and know that theories are only ideas until they have been fully tested or proven by experimental observation. Galaxies are moving away from each other, and this distance is measured by how far away they are from Earth. This led to the idea of the Big Bang. Hubble's law, which explained this idea, said that the world was getting bigger over time. This idea seems to be supported by things like cosmic background radiation, the redshift of light from faraway galaxies, and other cosmological trends. But it's important to remember that people who thought the Earth was flat and the sun went around it had proof from what they saw too, until new events or technological advances made things clearer. We're seeing a similar thing happen right now. Scientists were hoping that the new James Webb Space Telescope would answer questions about the theory of how the universe came to be. Instead, it may have found these 6 huge systems that didn't seem possible. This shows that science is always moving forward, and scientists need to be willing to accept new information and rethink old ideas based on the new information. The amazing discoveries have put what we think we know to the test and caused us to rethink an idea that has been around for a long time. Redshift is a tool that scientists use to figure out different measurements in their study of the world. The color of light changes as light sources and viewers move away from each other. This is called redshift, which is also called the Doppler effect. To get this, picture stopping and hearing a car coming up behind you. This car's engine sound gets louder as it gets closer, but it changes sound when it goes by or moves away. The sound waves change as the car moves, which is why this happens. What's more, when a light source, like a star far away, gets closer, the light changes to bluer tones. On the other hand, the light changes to redder tones when the light source goes away. The name for this effect is redshift. Physicists have turned redshift values into rates and distances that can be used to study the world. It's important to keep in mind, though, that even a small mistake in these numbers can have big effects. The old ways of evaluating are now being looked at again. The newest finds about our universe need to be looked at to see if they are really based on redshift mistakes, or if some scientists are just ignoring what we know now. This question needs to be carefully thought through, and the data and methods used in the study need to be looked over in detail. The constant evaluation and reevaluation of measurement methods shows how our understanding of constant study is growing. Many thanks for seeing the movie. As always, we want to ask you to leave your questions in the comments. Please click the like button and share the video with your friends if you liked it. Also, make sure you follow the channel so you don't miss any more videos like this. Thanks for watching, and we'll see you in the next one. This call to action gets people to interact with the content, which builds a community of people who are interested in and want to learn more about the current scientific debates. Scientists all over the world are still fascinated and challenged by the idea of exploring our universe, which has very large distances and many complicated things. Every new finding, from the earliest ideas about the universe to the newest ones made possible by cutting-edge technology, changes how we think about the universe and what we know. The history and formation of galaxies is one of the most important and long-lasting questions in astronomy. Many stars, gas, dust, and dark matter are clumped together in galaxies, making them look like huge towns. Not only is it important to figure out how galaxies form and change over time, but it's also important to test or confirm ideas that already exist. For instance, the Big Bang Theory, which was first put forward almost 100 years ago, says that the universe started as a single point that was infinitely dense and has been expanding ever since. This idea came from looking at how the universe is expanding and the cosmic microwave background radiation, which is thought to be leftover energy, and light from when the universe was very young. But new discoveries, especially those made by the James Webb Space Telescope, JWST, have called into question a number of important ideas that were core to the theory of how the universe came to be. Because it is so sensitive and clear, the JWST has found galaxies that look much bigger and further along than their age would suggest. There were 6 very large galaxies found that were formed when the universe was only 200 to 700 million years old, a very short time in its history of 13.8 billion years. The study team called these galaxies universe breakers because they are so big and bright at such a young age in the universe. They go against what most people think. The finding of these systems brings up interesting questions about how quickly the universe grew in the beginning and challenges current models of how galaxies form. The most popular ideas say that galaxies are slowly formed over billions of years as smaller systems merge and gas and stars build up. The fact that these huge systems were around so early in the history of the universe says that galaxy formation is much more complicated and may happen faster than was thought before. The discovery also shows how important it is for technological progress to change how we think about the world. Astronomers have found parts of the early universe that they couldn't see before thanks to the JWST's ability to look farther into space and collect faint light from faraway galaxies. These new ideas give us important information about the conditions and processes that shaped star formation in the early universe. These findings have effects beyond cosmology. They push scientists to rethink and improve current cosmological models in order to better explain the variety and complexity of galaxies that have been seen over very long time periods. They also show how scientific knowledge is always changing and growing, as new discoveries can lead to bigger breakthroughs and new ways to do study. The study of how galaxies form is still an interesting and quickly growing field, and scientists are still looking at and making sense of the data from the JWST and other observatories. With each new finding, we get closer to solving the mysteries of our past and learn more about the basic processes that have made the universe what it is today.